What we have here are two real-life mock-up satellites, actually. This is the PharmaSat. This was developed by NASA Ames Research Center. This was launched last year. It's what's known as a nanosat, or a 3-unit CubeSat. This is the control system. This is where the computer and the brain and the power supply of all this satellite goes. And then this is the payload section of the PharmaSat. PharmaSat launched last year, and it was for experiments in yeast with how they react in microgravity and in space radiation to specific kinds of drugs. But one of the cool things about this entire satellite option is that for future researchers, we can modularly replace certain sections for different kinds of research. For instance, this is a centrifuge, and in this device, we can spin a sample inside of it, so that you can test strictly for, you can control for gravity and understand what the differences are with and without gravity. This system here is on the order of millions of dollars. But what PumpkinSat and a private company has developed, a payload bus for nanosats, or for CubeSats, is this 3-unit device, very similar to this, as well as this 1-unit PumpkinSat. This is something that's controlled by USB. It's got its own computer on the inside. This is on the order of 10,000, maybe a little less, if you go to, I guess, their website, CubeSatKids.com. But this is something that's publicly accessible, where you can fit more of a payload in here. This is the control section here. These are solar cells. And this is what, you can launch this, either piggyback or find an independent rocket that can send this up and do whatever you like. You can throw a camera in there or whatever payload. But what's critically important about our project is that this control system is quite expensive. What we're really focusing on doing is trying to reduce the price of the control system through very off-the-shelf components. This is the Lego's NXT Mindstorms robot. It's this very toy that there's probably 100 of them around here. And what we've done is replicated many of the controls inside these satellites with this robot, or with the robot brain. We have a compass, we have accelerometers, we have gyroscopes, $100 gyroscopes that are toys, basically, that we're using as reaction control wheels. And when I mean reaction control wheels, is that this device, controlled by the robot, can turn and stabilize itself as these spin or slow down. And they respond to the compass, which can tell it to orient itself in whichever direction we want to tell it to do. This is under $1,000. The metal's a little more, but the principle of it is that we've replicated components rapidly using off-the-shelf toys. But the best part about it is that the accelerometers, the radio, the computer brain, and almost everything except for the gyroscopes are in these smartphones. You take away the monitor, you take away the keyboard. You have a battery, a camera, a brain with GPS, with compass, with the radio, with everything you would need to really control a satellite. And we're in the process of doing, in partnership with International Space University, with Stanford University, at NASA Ames Research Center, is taking all of the components inside these and emulating them and having them work functionally in the front half of these Android-based cell phones. And so we're able to reduce the cost from millions to tens to hundreds of thousands, all the way to a couple $100. And that's the point of our program.
Excellent. Thank you very much.